This is Bob Capetta, and the lesson is graphical analysis. So let's examine the following graph. What can we say about it? How is it behaving? What's happening with it here? Well, we can see where it's increasing. So you think about a roller coaster going from left to right. You imagine the roller coaster is on the curve. From left to right, you see it is increasing first. Now, what are the x values? Now, we assume this goes on forever. So it is increasing from negative infinity until it gets to negative 3. Once it gets to negative 3, what does the roller coaster do? It starts heading down. So this will be decreasing. The function is decreasing for which x values? It's decreasing on the interval from negative 3 to 2. And then what happens? Then it's increasing again. Then the function is heading up. The roller coaster is ascending. So it is increasing again. So we have it increasing on two intervals, negative infinity to negative 3 and from 2 to infinity. We have it decreasing on one interval. When we have it increasing on two intervals, we usually say it's increasing on the union of those two. So here's how we say that. We say the function is increasing on the interval negative infinity to negative 3 union 2 to infinity. That's the set where it's increasing. From here to here, together with from there to there. And it's decreasing from negative 3 to 2. Now, what's happening here? We're calling that a local maximum. Now, why is it a local maximum? It's not the highest point this function ever achieves, because it goes on forever in this direction. But in this neighborhood, around these x values, around x values of negative 3, the highest it gets is at 4.75. So we say that that function achieves a local maximum value of 4.75. Where? At negative 3. But it is not a global or an absolute max. It is a local. Now, how about the minimum? Is this the lowest it ever achieves down here? Well, no, because it continues this way forever. So the same thing, around this value of 2, the function achieves a local minimum of negative 5.667. So indeed, that's what we say. The function achieves a local min of negative 5.667 at x equals 2. There is no absolute max. There is no absolute min. Now let's think about the domain and range. Remember, the domain is the set of all possible inputs, the set of all possible x values. Well, we can see an x of 3 is on the function, an x of 2 is on the function, an x of 1, an x of 5, and 6 because it continues, and 7 because it continues, and negative 6 because it continues, and negative 7 because it continues. The domain is everything, right? It's all real numbers. Now, how do we write that in interval notation? We would say from negative infinity to positive infinity. Range, same way. How low does it go? It goes down as far as you want it to go. And it grows as high as you want it to go. So the range is also all real numbers. So let's take a look at our next question. This is what I have. Now, what can I say about this? A little different than the last question. We're interested in what's happening. Where is it increasing? Where is it decreasing? Decreasing here. You see that? Decreasing here. So what are the x values? Starting at negative 3 and then ending at 0 before the roller coaster goes flat for a while. So it's decreasing on the interval from negative 3 to 0. And then what happens here? The function is constant. From what to what? The x value of 0 to the x value of 5 before it starts increasing again. So the function is constant on the interval from 0 to 5. And then what happens beyond that? Then we say that the function is increasing where? As x ranges from 5 till 11. Now let's talk about domain and range here. Domain. What's the lowest x value you see anywhere? Negative 3. What's the highest x value you see anywhere? 11. So the domain for this function is from negative 3 to 11. So we see that again, smallest x value, -3, largest x value is 11. Everything in between can be used. Now, what about the range? What's the lowest y value we see anywhere? Lowest y value we see anywhere is -7, and the highest y value we see is 2. So from -7 to 2 will be the range. So again, lowest y value, -7, highest y value is 2. Everything in between is being used. That's our domain and our range. Let's take a look at another question. So we're interested in domain and range again here. What is the smallest x value you see that shows up on the graph? It's here. -3. Largest x value you see? Well, there's an open circle there, which means it gets close to 4, but never actually gets there. So how do we describe that? -3 square bracket to 4 is our domain. Now our range would be all the y values we have. It's not obvious what this lowest y value is, nor is it obvious what the highest y value is. So we need to get those numbers off the graph. So you can see the lowest y value here is -6.274. The highest y value is 3.5, and that's our range. From -6.274 up to 3.5, and everything in between is allowed. So let's see what else we have here. We've got some other points of interest. -2, 0 is the bottom of this valley. This 2.921, -6.274 is the bottom of this valley. And -0.171, 2.042. Pretty close to 0 too, but not quite there. That's the top of that hill. Now let's ask the question about absolute max. What's the highest this ever achieves? Well, we see it here. The highest y value ever achieved on this function is 3.5. So we would say that this function achieves an absolute max of 3.5. Where? At what x value? At x equals -3. Now about the absolute minimum. What's the lowest it ever achieves, the lowest it ever goes? Well, that's down here. So the absolute minimum of -6.274 occurs when x is 2.921. So we see that. Now, what else do we have? That's absolute max, absolute min. Do we have local mins and maxes? Well, the two I'm more interested in are these two, the bottom of the valley and the top of the hill. You could argue that this might be an absolute as well, except remember that was an open circle when we originally drew the graph, so we'll choose to ignore that. So do we have local minimums, local maximums? Well, this one is the smallest in its neighborhood. So at -2, the function gets down to 0, then it bounces back up again. So we have a local minimum of 0. Where does that occur? At -2. So right around -2, the lowest the function ever gets is 0. Similarly, we have a local max. What's the highest it gets in an area? Well, right here, okay. Near -0.171, it gets up to 2.042, never gets any higher, and then it comes back down again. So if that's the case, that is a local maximum of 2.042 at x is -0.171. So those are some values for us to look at. Now, what else can we talk about? Looking at this, what's happening first? Between -3 and -2, what is the roller coaster doing? It is descending. So the function is decreasing on the interval from -3 to -2. Is it decreasing somewhere else as well? Well, yes, it's also decreasing here. So x is -0.171 to x is 2.921. So we have two different intervals where the roller coaster is descending from left to right. How do we hook those together? We say that it's decreasing on those intervals with a union in the middle. Decreasing on the interval from -3, -2, union, -0.171 to 2.921. Now, where is the function increasing? It's increasing here. So as we go from -2 to -0.171, and it's increasing here. from 2.921 to 0. When I talk about increasing this and decreasing this, I never use square brackets because to me something is increasing or decreasing in an interval, an open interval. Personal feeling there. So what do we conclude? We have that function is increasing on the interval from -2 to -0.171 union 2.92124. So what do we talk about in this lesson? We talked about domain and range. We talked about increasing, decreasing, and continuous, where that happens with various functions. We talked about absolute mins and maxes. We talked about local mins and maxes. Those are various ways for us to do some graphical analysis. And that will conclude this lesson.